everybody, this is Miss Bufford and this is video 5 in our acids and bases unit, and in this video we're going to be calculating between pH and hydronium ion concentration and pOH and hydroxide ion concentration. Your learning goals for this video are to be able to calculate the pH or the hydronium ion concentration when you're given the pOH or the hydroxide ion concentration. In the previous video, we talked about how to convert between pH and hydronium ion concentration and also pOH and hydroxide ion concentration. And if you look at how I've had these set up right here, you can see that I've got an arrow pointing from pH to hydronium ion concentration, and there's an equation on that line, on that arrow in between there, and that's the equation we use to convert from a pH to hydronium ion concentration. And I have the same thing set up from hydronium ion concentration up to pH, so it's pointing up towards pH. And similarly, the equation for that would allow us to calculate the pH if we're given the hydronium ion concentration. And I have the same setup done for pOH and hydroxide ion concentration. And so what we're going to do in this video is we're going to learn how to convert between pH and pOH, and how to learn how to convert between hydroxide ion concentration and hydronium ion concentration. All right, so to get started, we need to first talk again about water's autoionization and something called equilibrium. So when water undergoes this autoionization, it reaches what's called an equilibrium, meaning that this reaction occurs in both directions, where hydrogen ions and hydronium ions are being formed and then reneutralizing themselves by reforming water molecules at the same rate. So if you take a look at the diagram of this picture up here, where we've got the two water molecules, and then we have a hydronium ion and a hydroxide ion, notice that the arrows in between that are going both ways. That means this reaction can go both ways, where hydronium and hydroxide will come back together to form those neutral water molecules. And when we reach an equilibrium in a system, then it just means that the hydronium and hydroxide ions are forming at the same rate as neutral water molecules in that solution. And so we reach a concentration of ions in this solution that is constant. Okay, and so the Kw value right here that you see down below with this equation is the equilibrium constant for water, and this is equal to the product of the hydronium and hydroxide ion concentrations, which is equal to 1.0 times 10 to the negative 14. And this, again, I just put this in parentheses. You don't have to worry about this for this class, but later on, if you take AP chemistry or if you take college chemistry, they will be talking about, different temperatures and how that can affect your equilibrium and stuff like that. So this relationship right here, the Kw and the product of the hydronium and hydroxide ion concentrations, is what the pH scale is built around. So let's take a look at what this has to do with the calculations that we're going to do in this unit. Okay, so when we're converting between hydronium ion concentration and hydroxide ion concentration, we talked before on the last slide about how the product of the concentration of hydronium ions and hydroxide ions is equal to that Kw value, or that equilibrium constant for water. So if we were to take all of the corresponding hydronium ion concentrations and multiply them by all of the corresponding hydroxide ion concentrations, then we actually start to see they're all equal to 1 times 10 to the negative 14th. All the way down the scale, okay? And so we have this equation. We saw this on the previous slide. And what this allows us to do is, if we rearrange this equation, it will allow us to calculate one of these concentrations if we know the other. So if we know hydroxide ion concentration, we can rearrange this to solve for the hydronium ion concentration. And just similarly, we can rearrange it. If we know the hydronium ion concentration, we can solve for the hydroxide ion concentration. And so what I'm going to do is I'm going to add some little arrows to my pH roadmap over here. And I'm going to move these equations over where they belong. So this is going to allow us to calculate hydroxide ion concentration. And this one will allow us to calculate hydronium ion concentration. All right, so now let's talk about converting between pH and pOH. So if we take a look up here at our pH and pOH scale, remember how the numbers that we got these, the place that we got these numbers from was actually the exponent on our ion concentrations. And so if we were to add these together, because when we multiply a number in scientific notation, the way that we handle the exponents is that we add them together. And so we're basically doing the same thing we did on the other slide. Now we're just looking at the exponents rather than the whole number. And so we add them all together and they all equal 14. Okay? So we can write this equation right here, pH plus pOH equals 14. And you can see that this equation can also be rearranged to be able to solve for an unknown value. So if we know what the pOH is, we can subtract it from 14 and that will tell us what our pH is. If we know what our pH is, we can subtract it from 14 and that will tell us what our pOH is. And so I'm going to add the last side to my pH roadmap over here, and I'm going to go ahead and put these equations where they belong. And now I have this really handy little map that tells me exactly which calculations I need to know how to do in order to do different conversions here using the pH scale and the pOH scale and then hydroxide and hydronium ion concentrations. All right, so let's go ahead and do some practice. All right, so in this part of the video, we're going to be doing some example calculations. The first two calculations we're going to do up here are going to be between pH and pOH. And then down here, we're going to be doing some calculations converting between hydronium ion concentration and hydroxide ion concentration. So let's go up here. We'll start with a pH equal to 6.3. And we need to determine what the pOH is going to be. And so I'm looking for pOH. So whatever equation I choose is going to have to equal pOH. It's going to have to be by itself on the equation or on that side of the equation. So I'm going to choose this one right here. And so my pOH is going to be equal to 14 minus the pH. And in this case, our pH, remember, is 6.3. And so in my calculator, I'm going to do 14 minus 6.3. And that tells me that my pOH is going to be 7.7. And since I'm subtracting here, the way I determine sig figs is the number that has the fewest decimal spaces. Since 14 is an exact number in this case, we're just going to use this to determine sig figs. And so my answer is going to be 7.7 for my pOH. All right, now let's go ahead and do the second one. So this time I'm starting with a pOH and I'm being asked to calculate the pH. And so I want to choose an equation that's going to be set up to be equal to what it's asking me for, so equal to pH. And that means I'm going to use this top equation right up here. And so 14 minus the pOH, which is 2.9. Okay, so then in my calculator, 14 minus 2.9, and that's going to give me 11.1. And again, 14 is an exact number here, so I'm going to be using the 2.9 to determine significant digits. And remember, I'm subtracting, so I'm more concerned with my decimal places. Since I have one decimal place here, I definitely want to have one in my answer. And so my final answer is going to be 11.1. So my pH is 11.1. And this would be, let's see, this would be an acidic substance, and this would be a basic substance. All right, Now let's go ahead and do some conversions between the hydronium ion concentration and the hydroxide ion concentration. And so this first problem right here is giving me the hydronium ion concentration and wanting me to calculate the hydroxide ion concentration. And so again, I'm going to choose the equation where the hydroxide ion variable is going to be on the side of the equation where it's by itself. So I'm going to set this equal to OH minus. And then I'm going to look over here at my pH roadmap. I'm working down here between the two ion concentrations. And I'm going to end up using this top equation right here because hydroxide's by itself, and that's what I'm trying to find. And so I'm going to set it up 1 times 10 to the negative 14th divided by 4.7 times 10 to the negative 4th. And when I put this in my calculator, again, I'm going to go ahead and use that E function. If you use the option where you're using the times 10 and then you use the little caret, just make sure that you're putting the entire number from that number in scientific notation in parentheses so that your calculator doesn't mess up the order of operations. Or you can just use the scientific notation function, which eliminates your need for the parentheses. So in this case, I'm going to hit 1, second E, and then negative 14, and then divided by 4.7 E, negative 4, enter. And that tells me that my hydroxide ion concentration is going to be we want to have two significant digits here, 2.1 times 10. And remember, in our calculators, when it gives us that little e, that just means times 10, and then whatever comes after it is going to be our exponent. So my hydroxide ion concentration here is 2.1 times 10 to the negative 11th. And there's my final answer. All right. Now let's go ahead and do the second one. So now we're being given the hydroxide ion concentration, and we need to figure out the hydronium ion concentration. So I'm going to set this equal to my unknown, so my hydronium ion concentration here. And I want to choose the equation where that's on its own on the one side of the equation. So that's going to be my second equation down here. And then I'm going to do 1 times 10 to the negative 14th. And divided by that hydroxide ion concentration of 8.3 times 10 to the negative 3rd. And so in my calculator, 1 second E, negative 14, divided by 8.3 E, negative 3, enter. And that gives me a hydronium ion concentration of 1.2 times 10 to the negative 12. And there we go. And again, when we write these concentrations, their units are really molar, so we can write in capital M after these concentrations. All right, I hope this was helpful. Let's continue on. Great, so now that we can convert between pH and pOH and hydronium ion concentration and hydroxide ion concentration, let's talk about a little bit more complicated calculations that we can do using our pH roadmap. So this pH roadmap is an easier way to keep track of all the required steps when we're calculating between different expressions of ion concentrations in acids and bases. So as you can see by looking at this pH roadmap that we've made, that there is no direct calculation to be able to calculate a pH directly from a hydroxide ion concentration. There's nothing going across this box to help us do that. Similarly, there's nothing going across this box from corner to corner to allow us to calculate a pOH directly from a hydronium ion concentration. So when we're performing these types of conversions or calculations, we're going to need to perform two separate calculations. Okay, and so let's go ahead and do some of those examples. So let's go ahead and practice. All right, so let's go ahead and do some examples. These are going to be our more complicated, and by more complicated I just mean two-step equations rather than just single-step equations. So the first example up here, we're going to be given the pH of 4.7, and it wants to know what the hydroxide ion concentration is. And so if we take a look over here at our pH roadmap, you'll notice that there's no direct route between pH and hydroxide ion concentration. So what we have to do is we have to choose whether we're going to go this way or this way on our map. Okay, it doesn't matter, you're going to get the same answer either way you choose. It's just I like to choose the calculations that are a little bit simpler. And so in this case, I might choose to convert pH to pOH first, and then convert that to the hydroxide ion concentration. So that's what we're going to do. So I'm starting with a pH, and I know if I need to convert pH to pOH, then I'm going to have to use this equation right here first. So I'm going to start off with pOH equals 14 minus 4.7. And that is going to give me, let's see, we'll do it over here. I have it all worked out, but we'll show you on the calculator. 14 minus 4.7 equals 9.3. So that means my pOH is 9.3. Okay, so we'll just go ahead and write out that new information. pOH equals 9.3. My handwriting looks really messy. Now we need to convert the pOH to a hydroxide ion concentration. So let's take a look at our roadmap. Now we're over here at the pOH, and we need to get down here to hydroxide ion concentration. So I'm going to follow this arrow, and that corresponds to this equation right here. So I know that I'm going to have to take the antilog, so 10 to the negative pOH, negative 9.3. So in my calculator, I'm going to go ahead and hit clear. I'm going to hit second log and then just negative 9.3. Hit enter. And so that's going to tell me that my hydroxide ion concentration is going to be 5.0 times 10 to the negative 10th. Right? So OH minus concentration 5.0 times 10 to the negative 10th. And that's molar. All right, so there is the first answer. And so see how we just used two of those equations. We just figure out where we are starting at, where we need to go, and then choose a direction on our map, and then just use the equations that it tells us to on the way there. So let's go ahead and do the second example. So in this case, it's giving me the hydronium ion concentration. So I'm starting out right here on my map, and it's asking me to calculate the pOH. So I have to get all the way up here. So this is my endpoint. This is my starting point. And again, there's no direct route across the way, so I have to choose a direction and choose the two equations that I'm going to use. And in this case, I thought it might be easier if I converted from hydronium ion concentration to a pH first. So I'm going to choose to go up this way. And so I'm following this arrow right here actually. And I'm going to use this equation right here. Right? So let's do that. Our pH is going to be equal to the negative log of our hydronium ion concentration, so 5.7 times 10 to the negative 10th. And if I plug that into my calculator, negative log of 5.7 E negative 10, then I get a pH of 9.2. So my pH here is 9.2, and it's asking for pOH, so all I have to do is go from pH to pOH. So I'm following this arrow right here, and that means I'm going to use this equation down here, right? So my pOH OH equals 14 minus 9.2. 14 minus 9.2, and I get 4.8 for my pOH. I'll go ahead and write that out officially. All right, there you go. I hope this was helpful. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.